Hello, and welcome to today's Ask a Scientist program. Myself and two of my fellow Museum of Science educators will be answering some of our favorite questions we've been asked about space. My name is Eric, my pronouns are he, him, and I'll invite my fellow panelists to introduce themselves as well.
Hi everyone, my name is Emily, and my pronouns are she, her.
Hi everybody, I'm Talia, and I also use she, her pronouns.
So I'll start with the first question, which is, what are the dangers from space junk? And it's not what you might think. It's not astronauts opening the escape hatch and tossing what they don't need out the window. It's actually things that come off of a space mission or are left behind by a space mission, or even an entire space mission that no longer works, orbiting around the Earth and staying there because no force is bringing it down to Earth. When we have an orbit that is something going around the Earth, gravity is pulling down on it, but its speed is so great that it stays in one path around the Earth. Those orbits are really fast for things going close to the Earth. Things that are further away, they're a little bit slower, but still thousands of miles an hour. And one of the problems we have now that we've been going to space for 55 years almost is there's a lot of debris from those missions. As rockets launch and then some parts come back down to the Earth and they release their payload to be a satellite or a rocket that's going to the moon, even tiny little nuts and bolts, fragments of missions, even flecks of paint can be left in orbit for an extremely long time. And those orbits can be stable for decades. And so there's lots of different agencies that track space junk. And in fact, they were tracking thousands of objects that are big enough to give a radar reflection so that we can actually keep track of them. Those objects are zipping around the Earth in orbits that are stable at thousands of miles an hour. And at those speeds, even something as small as a fleck of paint can be dangerous if it slams into your spacecraft. So the International Space Station has lots of people on the ground constantly monitoring its path around the Earth to make sure it doesn't intersect with anything else's path. We also have to make sure that we take care of our satellites. At the end of their life, we have to make sure that we bring them back down into the Earth, or we can put them up into kind of a parking orbit out of everybody's way. Because if two objects collide with each other, that means that two pieces of space debris can become thousands or millions of pieces of space debris. If there's too much space debris in one orbit, that would mean we can't launch a rocket through it, and it could really affect our ability to leave Earth. So space junk is definitely something where there's lots of dangers associated with it, but lots of people working to be able to mitigate those dangers.
Very cool. And I also know that space junk is dangerous because we're still creating it too. So we've got to find some kind of solution for how to figure that out.
Yeah, we're better than we used to be in the 60s, but we're not perfect yet.
Yeah, definitely. So my first question is from Clement when they were 8 years old, and it is, why is space black? And this is a cool question because there are a ton of stars in space that are constantly making light. So why is space not glowing from all of that light? So I have two parts to this answer. The first part is that we can only see the light that is coming from a star if it's coming directly to our eyes. So even though a star has light energy that is bursting out of it in all directions, we cannot see that light that is moving in all of those directions. We only see the path of light or the beam of light that is coming into our eyes. Or sometimes we can see light that has reflected off of something else and then traveled to our eyes. So for example, let me show off a quick picture for a moment. Ooh, I gotta get it into full screen too. So this is a photograph of a nebula that is in our Milky Way galaxy. It's called the Eagle Nebula. And this nebula is glowing, but that's because the stars that are forming within it have a ton of gas and dust all around them that is scattering the light that is coming from those stars. So we are seeing the reflected light kind of bouncing off of all of those pieces of gas and dust, which makes the entire nebula look like it's glowing. The problem with most of outer space is that we don't have these giant dust clouds everywhere. So mostly where we look, it's kind of just black and dark. Now, the second part of this answer that I'll share is that the farther away that you move from a light source, the dimmer it gets. So there are tons of stars, even within our own galaxy, that we cannot see because they're just too far away from us. And you can see this happen even with something as simple as a flashlight. When you hold a flashlight right up to your eyes, it looks really blindingly bright. But as you move it farther away from you, or if you have a friend walk down the street with that flashlight, eventually you'll see that flashlight get dimmer and dimmer and dimmer. And then if that friend is far enough away, you won't be able to see that flashlight at all because it's far enough away. So that's another reason why we're not seeing this constant glow in space from all of the stars that are out there.
So my first question involves a very cool space mission, and I love very cool space missions. The question came from Harrison, age 5, and who asked, what did New Horizons pass on its way to Ultima Thule? So New Horizons was a spacecraft that left Earth in January of 2006. It launched in 2006, and about a year after it launched, it passed Jupiter. This was the fastest spacecraft we've ever launched. So it reached Jupiter in only a year. It usually takes spacecraft several years to get that far out. And it flew by Jupiter so that it could actually steal some momentum from the planet in what we call a gravity assist to speed itself up to get it to its ultimate target, which was Pluto. And there was a pretty good reason we wanted to send it out to Pluto. It's because we couldn't see Pluto. We can't see Pluto all that well from Earth. It's really small, which means it doesn't reflect, it doesn't have a lot of surface area to reflect light. And it's really far from the sun, so there's not a lot of light for it to reflect, which means it's very, very dim. We can't see it very well. So what I'm going to show you here, these pictures are from the Hubble Space Telescope. Pretty much one of the best observatories ever designed. This is a telescope that has totally revolutionized our view of space. And this is the best it could do with Pluto. It's just that hard to see from Earth. So we decided we really wanted to know what Pluto actually looked like. We sent New Horizons out there. It flew past Jupiter on its way to cut 3 years off its mission. And 9 years after it launched in 2015, it got to Pluto, and we finally got to see what Pluto actually looks like. Look at that, it has details. And not just Pluto, but also its largest moon, Charon. Pluto has 5 moons. Charon is the really big one. And it really, we learned so much about Pluto from this mission. We learned it has nitrogen glaciers. We learned it has cryovolcanoes, which are volcanoes that shoot ice instead of lava. We saw the little wispy atmosphere that Pluto has. We now think Pluto might have liquid water under its surface, at least for some of the time. And the thing is, New Horizons didn't stay there. It technically flew right by it. So one of the things New Horizons flew by was Pluto, which was its primary target. And it kept on going and out into space past Pluto, which is where the Kuiper Belt is. And there was another Kuiper Belt object in its path. So the spacecraft still had fuel. So they was like, well, let's go check out this other object, which didn't have an official name. It only had a number. So the New Horizons team started calling it Ultima Thule. And on New Year's Day, was it 2019? New Year's Day 2019, New Horizons flew by what we were then calling Ultima Thule. And it looks like this, kind of looked like a dirty snowman. And we learned a lot about this object as well. And it finally got an official name, which was not Ultima Thule, but Arikoth. So this object is now officially called Arikoth, which is a Native American word. And as I recently learned, also the name of Eric's D&D character.
A wizard. All right, so our next question is one that seems pretty simple, but also doesn't have an obvious explanation. And that is, why aren't there any green stars? And it actually has to do not so much with the stars themselves, but combined with what our eyes do to perceive color. So stars give off light of every color. White light is made up of all the different colors of light mixed together. Green, red, orange, yellow, all those different colors of light combined make white. So most stars in the sky look white to us because they're giving off all those light colors at the same time in about equal amounts. The ones that look redder give off a little bit more red light than everything else, and the ones that look bluer give off a little bit more blue light than anything else. The ones that peak in the middle, sort of around yellow or green, kind of like our sun, well, they don't look yellow or green because they're also giving off lots of red and blue light, just only slightly less. And so our eyes pick that up, that mix of all the colors of light at once, as white. You never get a star that's giving off way more green light than everything else. And so we never look up in the sky and perceive a star as being green. We see everyday objects like my shirt being green because they are absorbing all the colors except green. So only that green light is hitting your eyes. But for a star, it's always giving off every color. There's sometimes slightly more than one end of the other, so they can look slightly red or slightly blue, but just never green. Any star that peaks and gives off mostly green light gives off enough other light that it actually looks white.
That's good. I'm pretty sure Kermit the Frog told me it's not easy to be green. So
yeah, for stars, it's impossible.
Very cool. So my next question is, how do meteor showers work? And this is from Prishna, age 8. Now, I like this question because we tend to hear about meteor showers in the news, maybe once a month-ish. So they kind of come and go. Some people make a big deal out of them. So this person was asking, like, what's the deal with those things? So basically, a meteor shower happens when our planet, as it is orbiting around our sun, kind of passes through a big cloud of dust. And that cloud of dust is left over from a comet, when that comet kind of passed by our planet on its way around our sun as well. So as our planet passes through these, what did I call it? These balls of dust, what happens is those little teeny tiny dust particles kind of get pushed through our atmosphere. And when that happens, they speed up in our atmosphere, they get really hot, they light on fire, and then they burn up and go out. So in our sky, especially if it's dark enough for us to see it, in our sky, they look like shooting stars. So they look like these little tiny things that kind of light on fire and streak through the sky, and then they disappear. And by the way, a shooting star is essentially one of these meteors as well. But they don't always happen during a meteor shower. So like I said before, there's, approximately one meteor shower every month. That's not exact, but it kind of works out that way. Some of them are easier to see than others. So for example, the Perseid meteor shower is a really popular one because it's usually yields a lot of bright meteors in the sky, and you can see them for several nights when they're most visible. So there's always a peak night, which is when the meteor shower is the best and you'll see the highest number of meteors. But if you go outside a couple days before or a couple days after that peak, you still might see some meteors, just not as many as during the peak. So it's nice to have a bigger window to be able to see that meteor shower. And it's always fun to have an excuse to go outside and try to identify these really amazing things that are happening in our nighttime sky.
So I have a question about another really interesting thing that happens in the night sky. The question is, how do the northern lights form? So the northern lights, or the aurora borealis, are the sort of partner phenomenon to the southern lights, the aurora australis. So they happen at the North Pole and the South Pole. And they're caused actually ultimately by the sun. So our sun is it's a nice energetic star, and it likes to occasionally throw off particles in solar flares. So just every now and then, because it's a very active star, it just sort of flares out a whole bunch of particles, which we call the solar wind. And as these things are traveling through space, if they happen to be traveling towards Earth, because the sun's flaring out in different directions all the time, some of these are going nowhere near Earth. If they happen to be traveling towards Earth they can get caught in Earth's magnetic field. So Earth has a magnetic field. It's why a compass works. And mostly, other than a compass working, we don't notice it, but it actually does a lot to protect us from this solar wind. If we didn't have this magnetic field, life on Earth would be a lot harder, because the solar wind from the sun would actually be hitting Earth directly and stripping away our atmosphere. That's kind of what happened to Mars. Didn't work out for Mars, but Earth has a magnetic field. And so most of that solar wind gets deflected around the planet. And I'm going to go ahead and share my screen again in theory. We're super suave about this. So here is sort of an artist depiction, and these crazy lines that look like a spider around the Earth are a depiction of the magnetic field lines. And most of the solar wind gets deflected right around the planet, which is great for us. Some of this solar wind gets caught in the lines and gets carried to the poles, to the north and the south poles. And these energetic particles from the sun excite the molecules in our atmosphere. And excited molecules like to glow. And so when we have a lot of these particles from the sun hitting our atmosphere towards the north and the south pole, we get the aurora, the northern and southern lights, because of these energetic particles from the sun interacting with particles in the very upper atmosphere of the Earth. Now, the stronger the flare from the sun, the farther down from the pole the lights can be seen. So it does happen that there have been times here in Boston where the northern lights have been visible. Usually we're too far south to be able to see them. But for a strong enough flare, we can see them from here in the Boston area. From the strongest flare on record, I think we've got reports of the northern lights being seen as far south as Florida, which was an event that happened in the 1850s and has not repeated itself since, which is good, because that was a really, really strong flare.
All right, our next question is a pretty short one. What is dark matter? And this has to do with a mystery of our universe where we kind of just said, well, we don't understand, let's just call it dark matter. The story is that we understand how things move in space because of gravity. If you look at the solar system, the planets closer to the sun orbit faster because the sun's gravity is stronger as you get closer. So Mercury is moving much faster in its orbit than Earth is, but Earth is moving much faster than Neptune way out in the outer part of the solar system. So looking at the whole thing, the closer you are to the sun, the faster your orbit is. The same thing works on the Earth. The International Space Station is zipping around the Earth every 90 minutes, all the way out at the moon. It takes 30 days almost a month to go around the Earth once. The further away you are from something, the longer it takes to orbit. When we look at entire galaxies, our Milky Way, of which the sun is just one star, that's made up of 200 billion stars, we expect it to work the same way. Everything is moving around the center of our galaxy where there's lots and lots of mass concentrated there. And so we would expect it to be that stars further out orbit more slowly. And instead, what we've seen when we've measured the rotation of galaxies that we can see is that it works much more like constant motion around, a lot closer to if a plate was actually spinning than what we expect to see based on what we understand of gravity. This was a really big mystery, and we don't understand it entirely. So there must be some extra gravity coming from somewhere. Maybe some extra matter is existing that we can't see in galaxies that would make it so that the galaxies rotate the way that they do. So we can't see this matter, but it definitely is matter because it has gravity. We called it dark matter. We're getting closer to understanding what it is by studying other galaxies. We have a couple of good candidates. Maybe it's just a kind of particle that doesn't interact with very much and never gives off any light. But right now, it's still one of the biggest mysteries in physics and astronomy. Just what is this dark matter that's causing these weird effects?
Super cool. Thank you, Eric. My next question isn't quite as exotic as dark matter, but it is, how do the planets get their color? And I love answering questions like this because it's really interesting just how unique and different every single planet within our solar system actually is. And each one has a really special kind of quality or trait to it. So this is just a very simplified model of our solar system. This does show off the size differences of the planets, but it does not show off their distance from each other. So for example, Jupiter is the biggest planet in our solar system, and you can see that it's the biggest one in this model as well. So the question was particularly about the colors of these planets. So I'll say that Earth actually looks blue from space, and that's because it is covered in oceans. And since water is also more reflective than land, for example, that means that the more prominent color that you would see from space is blue. And our planet has actually been called the blue marble when we look at a photo of Earth taken from that must have been taken from the moon, from the Apollo mission. So it basically has to do with what these planets are made of. That kind of designates what colors they actually are. So the other ones of interest to me personally, and I'm sorry if I'm leaving out your favorite planets, but Mars is a very interesting color because it is covered in this kind of reddish dust. We can essentially call it rust, but it's covered in this red dust that does reflect a red color. So that's why Mars looks red in our nighttime sky. Now, Jupiter is one of the gas giant planets of the solar system. So it gets its color from the gases that it's made of. And Jupiter has these really incredible stripes across it that are kind of brown and tan in color. And those stripes form because of clouds that are kind of hovering at different heights within the atmosphere of Jupiter. The Great Red Spot is red because that red spot is a giant hurricane or even a giant cyclone. You could think of it that way as well. That kind of dips down into the lower layers of Jupiter's gases and pulls up red gas. So that's why the storm is redder than the rest of the planet that we see. And then the last two that I'll mention are the last two true planets of the solar system, Uranus and Neptune, because we don't see blue in nature very often. So it's really awesome to see these other blue planets. Both of these are also gas giants, and they're both made of methane gas, which is what gives them that blue color. And Neptune is more blue than Uranus because it has a higher density of that methane gas.
Well, keeping sort of with the color theme, my next question is from, I hope I'm pronouncing this correctly, Aditi, age 10, who asked, is Red Antares bigger than the sun, and how old is Red Antares? So Antares is a star, which we can see in the summertime sky. It is the heart of the Scorpion, and it is a red star. It's a red supergiant, in fact. So the question about whether it's bigger than the sun, stars come in many different sizes. Sun's sort of middle of the road. There are stars that are way smaller than the sun, and then there are also stars that are way bigger than the sun. Antares was always bigger than the sun. It's a star that would have started out as what we would call a blue giant, which is bigger than what the sun is. So it would have always been a very large star. But now it's a very large star that is approaching the end of its life. And when really large stars get ready to run out of fuel, they swell, they get huge. So Antares started out a bit bigger than the sun. It's now way bigger than the sun. If you were to put Antares where the sun is in our solar system, I believe it would swallow, I think it's out past Jupiter. I think it swallows Jupiter. I don't think it quite reaches Saturn, or it's very close. So that's how big Antares is. As to how old it is, you might think it's a star and it's towards the end of its life. It must be really, really old. But it turns out those really big stars are also the shortest lived. So Antares is only like 10 or 11 million years old. That sounds like a lot, but compare it to our sun, which is 5 billion years old, and it has another 5 billion years to go. So the answer is yes, it's way bigger than the sun, and it's somewhere around 10 or 11 million years old.
Yeah. So the saying is true. The brighter you burn, the quicker your hydrogen runs out.
Yeah.
All right, we've got time for one more quick lightning round, and all three of us answering one more question. And so the last question I have for you today is, why is Venus hotter than Mercury? And that is a puzzling question because Mercury is much closer to the sun, about twice as close to the sun as Venus is. And so even though it's really, really hot, it not being the hottest planet in the solar system is a bit surprising. And it turns out the answer is the atmosphere of Venus. It has a thick atmosphere, 100 times thicker than ours here on the Earth, made mostly of carbon dioxide, which is really good at trapping in heat. So not only does it have the heat from the sun constantly bombarding it at a really close distance, it catches and holds on to that heat. And that means it's just a little bit hotter than Mercury. We've landed a couple spacecraft on Venus, but because of those intense conditions, they don't last very long. We've had spacecraft on Mars that have lasted for years. The longest a spacecraft has ever lasted on the surface of Venus is about an hour, and then it melts because it's so hot.
Very cool. Now, I had a quick question from Mateus, age 11, which is, why is the sun so hot? Eric just said that things on these inner planets get destroyed very quickly, but why exactly is the sun so hot? So first part of that is that it is really big. Our sun is so big that it could fit 1 million of our planets inside of it. So just think about how huge our planet is, the billions of people that live on it, the hours that it takes to, fly from one end of the country to the other. 1 million of our planets could fit inside of our sun. So it's really big. It's pumping out a ton of energy, and it has to pump out enough energy so that its own force of gravity doesn't make it implode and kind of fall in on itself. So it's kind of forced to push out enough energy to balance out that force of gravity. And also we feel those incredible amounts of energy because we are relatively close to our sun. We're obviously not as close as Venus and Mercury, but we're much closer than all of the outer planets, like all of the gas giants, Jupiter, Saturn, Uranus, and Neptune. So that is why our sun is actually as hot as it is.
All right, I've got a pretty good one for our last question because I think it's one that we should all answer. The question is, who is your favorite astronaut? And I'm very excited somebody asked this question because it means I'm going to get to talk about Dr. Mae Jemison, who's just a very, very cool individual. She was the first African-American woman in space. So, that's a thing. She's also, a medical doctor. So like she got her doctor's degree, like she got her medical degree and then decided to become an astronaut. So clearly she's, an overachiever because, oh my gosh, I got my medical degree and now I'm going to go fly into space. We really especially love her at the Charles Hayden Planetarium at the Museum of Science because she worked with us to provide a narrator voice for one of our planetarium productions, Destination Mars, which you can see playing at the planetarium right now. And I also cannot ever help but be really excited over the fact I'm a total nerd, which means I love Star Trek. And Dr. Jemison actually guest starred on an episode of Star Trek, which just really upped her cool level for me, as if all of her other accomplishments were not cool enough. She guest starred on an episode of Star Trek. So
that's probably at the
Jemison.
Top of her resume.
Right? Well, it would be at the top of mine.
Yeah.
Personally.
Oh, that's a good one. So I don't have a single favorite astronaut, unfortunately, so my answer will be a little more vague. But I'll start by saying that I personally would be terrified to go into space. I don't think I would do it if I was given the chance to do it. So I think that my favorite group of astronauts would have to be the Apollo mission astronauts. Some of the first people, specifically men, who went into space, but also who landed on another body besides our planet. It's mind-blowing to think about how terrifying that must have been to be those first people doing that. And it's also just amazing to think that they were able to accomplish that without all of the technology that we have today. Like it's I don't know how to say it. It almost seems like a miracle that anything even worked. So I just give major props to them for being some of the first. They just seem like some of the bravest people that I've ever heard of to say, yes, I'll go to that other foreign body in space and hopefully I'll see you back home.
Following along with the astronauts in recent years who've been up on the International Space Station, one that stuck in my memory as my favorite is Christina Cook. She worked on astrophysics missions and instrumentation for NASA. She spent some time at the South Pole, so she was kind of uniquely suited to go up to the space station and do some research. And she ended up having her mission extended there for quite a long time, and ended up staying for just shy of a year, which is almost twice as long as she signed up for in the first place for a typical 6-month stint. It ended up being the 7th longest single space flight by any astronaut in the history of humans being in space. And so it's really impressive that she did that on her very first space flight and got to do so many cool things like spacewalks and breaking all kinds of records up there. Well, that is all the time we have for today's program. I'd like to thank all of you for tuning in. If you have questions that you'd like to see us answer in the future, you can send them to us at sciencequestions@mos.org, and we might answer them on programs just like this or our podcast, Pulsar, that answers some of the most intriguing questions we've ever been asked at the Museum of Science. Thanks, everyone. Enjoy the rest of your day, and until next time, keep asking questions.